Welcome to a new test and teardown video. This time we're looking at a very old Siemens RK4A. I mean, this thing is a 1960 PLC. Really? I believe it can control some motors. We got something here with direction where you can change the direction of your motors. You can change how much capacitance and impedance of your motors, and we got some different timing. So that will be seconds, and then there's a motor, gearbox, and all that kind of stuff, and that will be different outputs, and you can adjust. See the output. You can't go higher than the previous, but you can go lower, and then you will move the other one lower. So what the heck is that? So this is the timing programming setup module. We got 4 powerful output relays, probably for some start and stop, brake, and stuff like that. We got current measurement and set points done like that. I can feel that it's affecting some sort of stuff in here. And this, what is that? So I believe we got some current going through here, and this is the timing device for peak current detection. This one is a current amplifier. It's actually a meter without the needle, as you can see here. So this is measuring probably current or voltage, and then it can hit some relays. You can see down here, it can hit these 2 contacts, and they will be amplified and driving some relays, probably for startup adjustments and all that kind of stuff. I've been trying to Google a little bit, but it's not really easy. This is the nameplate. If you are better to do the Google, please try and see if you can figure out exactly what this is. But I think we got the watts and all that kind of things here. We got the type number, and that is probably also a part of the type number. I don't know exactly what is going on here. Let's get some more light. It's 14 kilos. I think the top here is aluminium profile. We got a really nice plastic, probably acrylic or something like that. Look at that. Everything is super high quality. And that frame down here is big, solid aluminium frame. See, it was supposed to be inside a very big factory installation, and that is all we got of input output, and it's just marked 1, 2 and stuff like that, so I can't really do a lot. Maybe we can unscrew here and it will be connectors. I don't know. I will see if I can get everything off here so we can enjoy this technical installation. I would definitely call this a mechanical PLC from 1960 or about. I was about to unscrew the whole top and lift everything up, and then I realized there is a push switch here. Look what happens. Maybe it's easier to see. This one can activate probably all those relays. So, oh, look at that. Oh, this resets this is an error indication, or this one was tripped indication. Look at that. And then you push here, you reset the indication. Mechanical indication. This is really nice. It's just an amazing construction. Let's look a little bit at the left side and the bottom. We got tons of resistors here. I believe those are resistors. I am not completely sure. But it must be power resistors, right? So what is going on here? Yes, look at that. So all that stuff here, that is power resistors. And we got some inductors here, or some tappings, so we can select the different inductors and stuff. Oh, I got some few inductors up here. Oh man, what the heck is... And here is our timing programming section. There's definitely some sort of a funny spring. I mean, something is going to turn this way. There's a gearbox. This is probably some sort of a motor in here. I can't wait to pull all this apart. And that one, still haven't figured out yet what is going on here. It's probably some sort of a... Oh yeah. So this is a relay that is not supposed to move too fast. So when a peak current or peak signal comes, then see, it is time delayed by this, by the weight of that material. Boing. And then there is a relay. Really cool. I have not seen that before. Oh, that is nice. And then, yeah, that's definitely current going here, right? And then you can adjust how... so there's just a variable spring, I suppose, right? Yeah. I don't know if it's here. It goes real loose. Oh yeah. Then it tightens. So that means a lot more current is needed to activate. This one is now quite hard. And then see, there's a little contact here. And then it goes looser and looser and looser. That is something I can test and see if those amps are actually really right. I'll just take everything apart and play with each of the different modules. That is cool. This is the top and the right side of the unit. Look down here, it's full of transformers or inductors all the way through. I think it's possible to lift it up and have a look at the bottom part. See all those? What is that? Transformers or inductors or some kind of stuff that will activate these massive relays here. I really like the indicator and the reset. How cool is that? Just can't stop looking at the different parts here. Everything here is just absolutely alien technology. Ultra old, really nice stuff. What exactly is that? Probably capacitors or diodes or something like that. They need a little bit more investigation. It says not a lot on it that I can read. Yeah, I want to pull everything completely apart here. There's, by the way, a very intense stink. This smell here is like in the level of stinker. I don't know what I want to call this. It's, I don't know, old oil and Pertinax circuit boards and I don't know, just old melted plastic or something like that in a nice mix. Yeah, it's just full of all sorts of cool things. See, this is probably the inductor for the motor, so yeah, this is an inductance motor, wouldn't you guess? So I'm playing a little bit here with the bottom part, the terminal blocks. I was able to get one out, and look at those big, hefty, solid wires. So here's how that works. They're mounted this way. So to access all the screws, you need to come from the bottom side. I mean, that is very difficult to do, really. And then they're screwed in like that. So you probably do all the mounting and stuff, and then you mount this whole unit, and then you can never ever access any of the screws. That's weird, right? The screws are really good and tough quality. And here is the piece of metal here. There's even a little stopper in the middle. So when this is assembled, those wires, they go exactly where they're supposed to be, and the entry wires, they also go exactly where they are meant to be. I mean, they thought about everything. So I finally got it out of the box. And this is the bottom side. So there's a high voltage capacitor, low voltage capacitor. Got 5 ohm resistors, plus minus 2%. Wow. And that will be some current transformers. I believe this is just an inductor. And those are very complicated. Doing all sorts of windings in, out, phase current kind of stuff. But it's beautifully made, really. And there's another one of these interesting diodes things, maybe. I want to try and pull everything apart here and see what that is really. I can't read exactly what it says up there. Maybe it's mesclin and then G1941-1. I think this is definitely a selenium diode or something like that. We can probably open it and have a look. Let's see if I can be very... Oh, yes, it is. Look. And this is classic for selenium rectifiers. We got a little spring here that pushes. We need to be really careful about the different metal parts here, and that will be the selenium diode pieces. Here we go. That is how it works. This thin layer here will be the diode. Now I'll try and carefully put this back together, and hopefully it works. So it is a bridge rectifier, as you can see here, right? So yes, it is a bridge rectifier selenium. And the fun thing is that, look at that. The forward direction is quite low at low current, 0.2. And if I go the other way, there is of course nothing. And if I go from the other one here, it goes this way. So yes, of course, that will be the AC input, and that will be plus and minus output. How nice. I think I'm gonna save these. They're absolutely cute. If you want to build some really funny old steampunk kind of laggy things, I don't know. Definitely funny. So I took out this timing programming unit, and it is absolutely amazing. I also find a little bit deeper information here. 24 volt, 50 hertz on the motor. And look, there's a little piece here, and this is what the relay here is actually controlling. This little pin touches this one. So the relay can reset this per remote, because as you can imagine, when time goes, you need to reset it either manually or using this one, I guess. Then the motor will probably reset this. Yeah, what else can I say? I think I figured out how this works. If you look really careful in there, right? Oh, let me see if I can show you guys this. See, here. Can you see now there's a contact, now there's not. So I believe something in here rotates. How about we just power up the motor and see what happens? Let's try and see what happens. It's not moving. Why are you not moving, dumb motor? So the motor is not moving because it's open circuit. That is why it's not working. So there's no contacts or nothing. Look at that. The windings goes directly to the motor and there is no connection. Maybe I need to measure it all the way here on the blue wires. Aha! Here we got connection. But when I measure on the black wires that's coming out here, we don't have a connection. So that was it. We don't have a connection here because somebody screwed the wires on the isolation probably. How is that done? No. That is not done wrong. Yeah, here it is done wrong. It was touching up here on the isolation. Maybe we have a connection here. Yes, we do. Haha, now I can make it work. It's that easy to fix. We don't know if we get only one chance, so I will try and power it up now. Oh, did you hear that? So it's moving. Look at that. Is it going to stop? It just stopped like that. Oh. And then it resets itself. Oh, it's really nice. So how are you going? So it goes back using a spring or some stuff. But how do we reset the... How is that working? The nuts moving. Oh shit, man, that's shock. Okay, so this is definitely a fast release. And that didn't work with the power on. All right. That is a cool device. Really a funny relay. See, there is some sort of a time delay thingy. Wow. So here's this fantastic part I was talking about. I don't know if you can see this, but this is definitely the inner part of a normal mechanical meter, but there is no readout or anything like that, but there is a contact. So when I move this like this, you can see here is the contact. Of course, you can't pull a lot of current through a contact like this because the contact point is made using like really thin material, but this is probably enough to drive one of the relays. Fantastic unit. That is definitely also one of my funny keepers. I kind of collect all these funny items anyway. It's so funny to have a bunch of funky stuff to show to my friends. So here is this current relay, variable programmable maximum current detection or something like that, right? So if I put it here, should probably be 5. And then it works by adjusting this spring. That's just defining how hard it is to pull the contact. See, there's a nice little contact here. That seems to be working quite well. And at the moment I have enabled 4 amps. That's 4 amps, nothing happens. Let's go to 5. Yes, and then it works. How cool is that? Let's try and adjust this for 6 and see it's not working at 5. No, it is not. And then I give it 6 amps. It really works. I mean, I could really find some kind of cool use for this. But how old is this technology? Can you imagine? When was this designed? And why is this screw, by the way, not mounted correctly? Oh, this is probably for adjustment. No, I don't believe so. Those are really cute. So there's not a lot more to discover of cool items. That's just the relays, and they're super boring to look at, really. So all I wanted to say is thank you very much for watching. I hope you had a little bit of fun and entertainment. And what a lot of funny, funky stuff I saved today for my little display shelf of funky stuff. Funky junk.